Welcome to class of physics. In previous video we studied about different configuration of operational amplifiers. Now we are going to study about the application of operational amplifiers. Sure, before that let's see the concept about virtual ground. Sure, virtual ground, the name indicates it is virtual, not a real grounded. For some purpose we can consider it is an equivalent to ground. In op-amp, the term virtual ground means that the voltage at the particular node is almost equal to ground voltage. It is not a physically connected to ground. Virtual ground concept is very useful in analysis of operational amplifier when negative feedback is employed. It will simplify a lot of calculations and derivations. Okay. Virtual ground means it is not a real ground. Physically we are not going to make the connection between ground and the particular point. It is imaginary point where we consider it acts as a zero potential point. Okay. So particularly there is a node in negative feedback amplifiers. Okay, how to consider a point as a virtual ground, that we call it how to construct a virtual ground point. One is a voltage divider using two resistors can be used to create virtual ground. If two voltage sources are connected in series with two resistors, it can be shown that the midpoint becomes a virtual ground. See here, two voltage sources are connected in series with two resistors. There are two voltage sources. These two voltage sources are connected with two resistors in series. In these conditions, this point we call it as virtual ground. See in this diagram. So there is a source, input source, and there is a output source. In between there are two resistors are connected. So the midpoint of these two resistors, that we call it as virtual ground. Now this point the potential is 0. By considering a amplifier circuit, so here is a amplifier circuit. There is negative feedback, that means inverting amplifier. Here two voltage sources, one is input voltage source, then another one is output voltage source. In between these two there are two resistors. One is input resistor R1 here, and another one is RF, that is feedback resistors. These two resistors are series with these two voltage sources. Now the midpoint between these two resistors is this one. This point we consider it as virtual ground point. And at this virtual ground point, the current is not considered to be sync with the ground. That means zero current is sinking. So this is about virtual ground concept. So next go for the applications. One such application of operational amplifier is summing amplifier, or adder we call it as, or average amplifier. Summing amplifier is same as inverting amplifier, except that it has several input terminals. Okay, so here is an inverting amplifier. I will bring this here. Okay, comparing these two are the same diagrams, same conditions, that is inverting amplifier. So this is op-amp. Now there is a feedback resistor. Here also there is a feedback resistor. Output is here, output is here. The non-inverting terminal is grounded. Here also non-inverting terminal is grounded. But at the input there is only one input source, P in is there for inverting amplifier. But for summing amplifier there are several voltages applied to the inverting terminal of the amplifier. Here there are several voltage are there. Here only single input voltage is there. Okay, so this is the difference between summing amplifier and inverting amplifiers. Now what is the output here? In inverting amplifier, the output is equal to P out times gain. Here the gain is, for closed loop, the gain is Rf by R1. So that we can say that phi out is equal to minus of Rf by R1 into phi in. This negative sign indicates it is inverting, the phase reversal is there. Now what is the output of the summing amplifier? Here output of summing amplifier is equal to, so minus, it is inverting mode, for that I am writing minus, the gain Rf divided by, there are 3 resistors, okay, 3 resistors, that is voltage is dividing, for that R1, R2, R3 is there. I will write in 3 steps, 3 terms, Rf divided by R1, the voltage is V1, plus Rf by R2, voltage is V2, plus R3 by V3, R3 by Rf by R3 to V3. So this is the output voltage. Here it is the output voltage of summing amplifiers. Now how it will work? Let's see, there is small derivations to obtain this expression, output voltage expressions. I will erase all this. It's working. Now there are 3 currents, I1 through resistor R1, current I2, zoom it one, 3 voltage sources are applying, V1, V2, V3, and 3 resistors are connected to those voltage sources R1, R2 and R3. Here due to this there is a current I1 through the resistor R1, and current I2 through the resistor R2, and current I3 through the resistor R3. 3 currents. These all 3 currents are summing here at this node. So I1, I2, I3 becomes here I, and this current will flow through the feedback resistor at the output terminal. The current not flow through the amplifier because it has infinite input resistance. Okay. Using this concept, we are going to derive this expression for output voltage. I1, I2, I3 be the currents through I1, I2 and I3. These are the currents through R1, R2 and R3. Okay, now write the equation for these current by applying Ohm's law. I1 is equal to, that is Ohm's law is what? Phi equal to IR. Okay. For that I equal to Phi by R, so it is Phi by R. What is I? I is the current through resistor 1, for that is R1, and the potential difference across that resistor is, here the potential difference across this resistor is 1 is V1. Here I am considering the virtual ground concept. Here 2 resistors are series, so this R1 and RF resistors are in series, 2 voltage sources are there. Now the midpoint of this point, this node, point K is virtual ground, so that is equal to 0 potential, or in previous derivation we take it as Vx. So Vx is 0. Now the potential difference across resistor R1 is what? One is V1 and another one is Vx, so that V1 minus Vx is 0, for that it becomes V1 only. I1 equal to V1 by R1. Then what about the current I2 through resistor R2 through this? Now this R2 and this RF both are in series between 2 voltage sources. This midpoint is virtual ground again. For that I2 equal to potential difference across resistor R2 is V2 minus Vx is 0, for that it is V2 divided by the resistor value is R2, and the current I3 is same, so I3 can be written as V3 divided by R3. Yes, we got 3 current equations, but the current I is flowing through resistor RF. Now all these currents are summing at this point. These 3 currents are summing at this point. so becomes equal to I, and this I current is flowing here through the RF resistor. For that, the current equation for I value, I will write once again. I is equal to RF I equal to potential difference across these points. Here 2 point sources, one is Vx, virtual ground point here, and another one is output. So here Px minus P out, so Px is 0, it is minus of P out divided by RF. So this is the current. We got 4 current values, I1, I2, I3 and I value. Apply Kirchhoff's node rule here. So that is current at a node is equal to current leaving the node. Here at this point 3 currents are adding and are coming towards this node, and a current I is going out from that node. For that, the I value is equal to what? I1 plus I2 plus I3. Okay, what is I value? Minus P out divided by RF is equal to, what is I1? I1 is here P1 by R1 plus I2 is P2 by R2 plus I3 is P3 by R3. So P out is equal to minus of P1. Okay, this RF is multiple for all these 3 terms, so it is, I will write it as RF divided by R1 into P1 plus RF divided by R2 into P2 plus RF divided by R3 into P3. Okay. So this is output voltage of summing amplifier. Now let us consider 3 resistors are having same value. So that is R1 is equal to R2 is equal to R3. All these 3 resistors having the same value of R, then this becomes R and R. Then you can take it as common R. And also the feedback resistor is equal to RF. RF is also equal to R. In this condition, what happens? P out is equal to minus of R divided by R P1 plus R divided by R2, sorry, this is R into P2 plus R divided by R P3. So these get cancelled. The only output is minus of P1 plus P2 plus P3. Yes. What it indicates? The output voltage is equal to sum of all input voltage. This negative sign indicates it is phase reversal, okay? Not minus of voltage, it indicates phase reversal, so that the output is sum of all input voltages. So like that we can use the amplifier as summing amplifier to add the input voltages. Yes. Okay, and next one more application is phase shift oscillator. Here phase shift oscillator consists of an operational amplifier and 3 RC phase shift circuits, okay, or network, that we call as network. RC, RC, RC. So these are the 3 phase shift networks. Here at a particular frequency, the phase shift of each section of RC network is becomes 60 degree. At a particular frequency, that particular frequency take it as F0. So at a particular frequency there is a phase shift between each networks, so that is 60 degree. So here 3 networks are using RC, 1, 2 and 3 networks are there. So each network will make a phase shift of 60 degree. Okay. Totally it makes 180 at a particular frequency. There is a shift is what? 180 degree. Here this 180 phase shift is by the RC network, but here there is a amplifier we are using. That amplifier is also make a phase shift. That phase shift of amplifier is 180 degree, so that this amplifier makes 180 phase shift. This is makes 180 phase shift. So this is 180 plus 180, so that is equal to 360 degree phase shift, or you can take it as 0 degree. So total phase shift by the phase shift oscillator is 0 degree of 360 degree. So the particular frequency is calculated as f naught equal to 1 by 2 pi square root of 6 RC. Here RC is taking from the RC network, so each resistors are having same values, and also capacitor also consisting of the same capacitance value. Then the frequency is 1 by 2 pi root RC, 6 into RC. So there are some conditions to achieve this 0 degree or 360 phase shift. So that condition is the gain of the amplifier. Here the gain of the amplifier must be equal to 29. Must be equal to 29. What is gain? So how to achieve 29 gain? Here the gain equation is written as A equal to what? It is RF divided by, okay, RF is what? Feedback resistor value. RF divided by the resistance used here, R1. Okay. Or for another network it is RF by R2. For another network RF by R3. For first network the gain is RF by R1. Okay. Here this gain should be equal to 29. Then we can achieve this, make the 180 phase shift by these three networks, and total of 360 or 0 by the whole oscillators. Now, so for that the feedback resistor value RF equal to 29 into R1. That means the feedback resistor value used in amplifier is equal to 29 times the resistor used in the network. For example, if you take 1 kilo ohm resistor for R1, these resistors, then the feedback resistor should be equal to about 30 kilo ohm. Okay. So this is the condition to achieve the phase shift oscillators. Then the f naught, that particular resonating frequency f naught is 1 by 2 pi root 6 RC. So that can be simplified as 0.065 divided by R into C. Okay, this is about phase shift oscillators. So using operational amplifier we can make a phase shift oscillators. So in next class we will go for another application, Wien bridge oscillators, and finally we can solve some problems based on operational amplifiers. Okay. Now take the assignment questions. What is virtual ground? How to find the location of virtual ground or point of virtual ground? Thank you.